अच्छा चलो ठीक है can everyone hear me?
Yes.
ठीक है just one second. अच्छा now this is the paper that we are going to do. This one is February March 2020. ठीक है, we're going to try and do P5 and hold on a second. So starting with the first question, ठीक है, so the question is about so this question is about he's saying that he's got this brass and it's an alloy of copper and zinc, and so it's an alloy of copper and zinc, and typical copper concentrators. Mike किसी को on है, just a second. Let me just add people. So typical copper concentrations vary from 50% to 85% depending upon the properties needed in the alloy. There may be a small amount of other metals as well. Just a second. As a student found a method to determine the percentage of copper in a sample of brass. A known mass of brass powder, so remember, so it's copper and zinc, that's what brass is, and he's trying to figure out what is the percentage of each element. A known mass of brass powder is reacted with an excess of concentrated. हाँ ठीक है Zoha, end के ऊपर ठीक है. Better let's do this paper, then we can solve the doubts at the end. I said, now a student found a method to determine the percentage of copper. A known mass of brass powder is reacted with concentrated. So it's reacted with concentrated nitric acid. And एक second. I said it's reacted with concentrated nitric acid. Both the copper and the zinc and any other metal present are oxidized into aqueous ions by nitric acid. The amount of copper ions present can be determined by a titration technique. Okay, so there's some titration technique which is going to help you determine that. Using a weighing board to accurately weigh by difference the approximately 2 grams of brass powder and place the brass into a small glass beaker. So he takes the brass and places it into, so he weighs it basically and places it in a beaker. That's the first step. Step number 2 is in a fume cupboard, add approximately 20 cm of nitric acid to the brass in the beaker. Allow the brass to completely react to form solution A. So solution A is this thing. So copper from the brass is going to end up reacting with nitric acid. Dilute all of solution A. So he reacted 20 cm of nitric acid, but then he diluted all the solution to form a 250 cm solution, that's B. So this entire thing, which is basically copper nitrate, is now solution B. So after that, what he does is he places 25 cm of solution B into a conical flask. So now he's using just 25 cm into a conical flask. Using a dropping pipette to add aqueous sodium carbonate to solution B in the conical flask until there's no more acid present. So he's probably adding an excess of nitric acid. And then what he does is that he adds sodium carbonate, which basically neutralizes the excess. So it helps to neutralize the excess acid that's remaining. Adds approximately 20 cm of potassium iodide into the conical flask. A white precipitate forms, as well as a brown solution of aqueous iodine. Fills the burette with 0.1 mole per dm cube thiosulfate, Na2H2O3, so it is ready for titration. Step number 8, carries out a titration of the aqueous iodine produced in the conical flask against 0.1 mole per dm cube sodium thiosulfate. So one by one, I'm going to write everything down in a simpler way, all of the steps. So one by one, the steps are that he weighs the brass. which is basically copper plus zinc. Then what he does is that he dissolves it in nitric acid, excess nitric acid. After that, what he does is he turns it into, by adding water, he turns it into a 250 cm cube solution. Then what he does is that the excess nitric acid is removed by adding carbonate. So your solution basically now contains copper 2 plus ions. So what he does now is that he takes those copper 2 plus ions, only 25 cm cube of those copper 2 plus ions, and he kind of reacts them with potassium iodide. So probably there's some copper 2 plus and potassium iodide reaction, which we don't know. Okay. So the copper dissolves in nitric acid, forms copper plus 2 ions, and there's some reaction that happens over here with Ki, and iodine gets formed. He's saying that a white precipitate forms as well as a brown solution of. So some white precipitate forms. He did not tell us what the equation is. And then he reacts. He fills a burette with 0.1 mole per dm cube thiosulfate, and he does a titration of the flask. So your titration now is done with this flask over here. So it's titrated with Na2S2O3. And he's given you the concentration, everything is given. So this is 0.100 mole per decimeter cube. So remember, you should open this paper at your site as well. Okay? Remember, this is March 20 question paper 5.2. What's going to happen after this? What's going to happen is that outline how the student should accurately weigh by difference in step 1 in order that the exact mass of brass is added into the glass beaker. Include a results table with appropriate headings ready. So you just have to you have to make a table. So what that table should include is how do you measure the brass by difference. Mass is always measured by difference. So he had added the brass into a boat. So there's mass of boat plus brass / grams. Then what you're going to do is the other heading of the table would be that what he did after that was, after weighing it, he transferred it into some sort of container over here. In a fume cupboard, he added approximately 20 cm of nitric acid to the brass in the beaker. So before transferring it from the weighing board into the small glass beaker, what he's going to do is you're going to measure the mass of boat plus okay, so once you've used your brass, so it's the mass of empty boat basically. After you've transferred it, or residual. So once you have transferred all the brass into this other beaker, and then you're going to take a difference, which is the mass of brass that is transferred. So make lines, draw a table, and over here it's the mass would be in grams. So this will be mass quoted in grams. It's going to be, the heading will be on top of that, not over here. Now suggest why it is necessary to do step 2 in a fume cupboard. Reason you do step number 2 in a fume cupboard is that one of the gases that is produced in step number 2 when you added nitric acid to copper from the brass is that NO2 gas gets produced, and NO2 gas is a toxic poisonous gas. Maybe they did mention this in the question. Probably not. They did not mention this, but remember NO2 is a toxic poisonous gas. It's a brown gas and it's poisonous. Outline how the student should carry out step number 3, including the name and capacity of the suitable piece of apparatus in which solution B should be prepared. So step 3, how would you do this? So it's a simple step. All you have to do is that whatever happened in the first step, this was happening in a beaker. That you took brass had copper, and he reacted with nitric acid, and you got a result, which you got all of this. But he only used 20 cm³ of concentrated nitric acid, then he diluted it to 250 cm³. Now, the apparatus in which solutions are prepared, in which specifically where they're diluted, that's a volumetric flask. So what you're going to do is transfer the content from the beaker into a 250 cm³ volumetric flask, wash the beaker and add the washings as well into the volumetric flask, and then fill it up with distilled water and make it up to 250 cm³. So 2 marks, this is what you're going to do is, so transfer content of the beaker into volumetric flask. Tell them what the capacity is, because they did mention that you have to tell them what the capacity is going to be. Rinse the beaker and always rinse it not with water, with distilled water. Always don't forget to write distilled water. So after that, add the washings. Into volumetric flask. And once that is done, fill the burette up to fill the volumetric flask up to the mark. Now the next one is name the apparatus needed to transfer solution B into a conical flask. So in that case, he was just looking for a pipette. 25 cm³ was transferred. State how the student would know there's no more acid present in the mixture in step number 5. So in step number 5, he had added, to neutralize the excess acid, what he had added was sodium carbonate. Now, one thing that happens is that sodium carbonate produces a gas, which is carbon dioxide, when there is acid present. If there is no acid left, if no more acid is present, no bubbles of carbon dioxide gas are going to be produced. So carbonate is added to neutralize the acid, and carbonates, they produce effervescence. So how the student would know there's no more acid, there's no more effervescence or bubbles of CO2 gas. Then what he does is the student is given 200 cm³ or 0.1 mole per dm³ Na2S2O3. Outline how the student should use the solution to fill the burette in step number 7. And so it is ready for titration. So basically, and include any relevant procedures the student should follow to ensure the burette is correctly filled before any readings are taken. So all you have to do is, so basically over here he's asking, before the titration, how do you fill the burette? That's what he's asking. So remember one thing, that the 2 things that have to be done always when you're trying to fill the burette. One thing is, always wash. If you're using the burette for HCl or with Na2S2O3, or you want to use it for any chemical, always wash it with that particular chemical. So rinse the burette. With some Na2H2O3. And remember, this only applies to the burette. Any other flask in the titration, that will be washed with distilled water. As I rinse the burette with some Na2H2O3, and the next thing is that at the bottom of the burette, right at the top, some air is going to get trapped when you wash it. So one thing is you rinse it, throw away the washings, next step is fill the burette. It's not necessary to fill it till the top. He's just asking to fill the burette, not to, but he's not talking about the meniscus. So fill the burette and allow a small amount to run so that air is not trapped. Specifically in the nozzle. Okay, so whenever you fill it, two things. One is that you always wash it with the substance that you're using it for, and once you fill it, allow a small amount of it to run so that the air is not trapped in the nozzle over here, right at the bottom. Okay, is this clear?
Yes, sir.
A second part. And remember, this is standard operating procedure of preparing a burette. You always remember this. Next part is complete the table, and so tell me what the values are for the first one. It's 20.5. He did 4 titrations. There was a rough one. What's the second value for titration number 1? 40.25 minus 20.6. What would that be? This is 5 minus 0. That's
19.65.
let's say 19.65. What's the next one?
19.90.
So that's obviously 19.90, and then you have 5 and
19.75.
19.75. So anyways, complete the table, calculate the mean titer used in calculating the percentage. First thing, which values will be calculated? The one that are concordant values, the ones that are within 0.1. So I think it's going to be these two values. That's going to be 19.75 and 19.65. Show the working how the mean titer is calculated. Show this clearly. Don't miss the working. Because he said that show your working. A lot of people actually miss this. So 19.75 and divide that by 2. So that's going to be 19.70. So that is the amount of thiosulfate that's being added. The burette used by the student has a graduation of 0.1 cm cube. Determine the percentage error in the titer measured in titration number 2. Now, for every as you always show your working, all of it. Don't directly try and answer this one. First thing, what's the error? The error is the smallest graduation divided by 2. So it's plus minus 0.05. But also remember that titer values are calculated by using a difference of 2 values. When you take a difference, the error adds up. So the actual error is now 0.05 times 2. Always, whenever 2 values are getting subtracted or added, the error in an individual value, it gets added up. So your titration value over here, 19.71070, actually has an error of 0.05 times 2. So that's your error. How do you calculate the percentage error? It's the error over the actual value. The actual value is 19.70 and multiply that by 100.
सर ये बात एक्सप्लेन कर दें कि ये मतलब 0.05 into 2 मुझे ये बात एक्सप्लेन कर दें।
इसमें होता है कि ये आपको पता है कि एरर होता है कि it's the smallest graduation divided by 2, right? Is that clear?
Yes sir.
Physics
Yes.
के अंदर there's a thing whenever you add or subtract two values. नहीं, Javed, the least count is actually 0.1 in a burette. The reason you write it as 2 decimal places is because the error is actually 2 decimal places. Okay, let me just one by one answer. Take the first one. Okay, why is it getting multiplied by 2? Remember one thing, that whenever, this is a rule, that whenever two values are getting added or subtracted, for example, there's a value that's 2 and the error in it is plus minus 0.02, and there's another value which is 3 and the error in that is plus minus some random values, 0.01. If you add or subtract these two values, let's say I'm adding the two values. So the value is going to be 2 plus 3, that's going to give you 5. But the error is going to now add up. It's now going to be 0.02 plus 0.01. So it's going to become plus minus 0.03. So now that's a rule. There's an explanation for that as well. And the explanation simply is that, I mean, I can go into a bit more detail, which is not necessary at the moment. But one thing is, you just remember that subtracting or adding errors add up. Okay, like, and I'll just show you an example why they add up. Let's say I have a value which has an error of 0.5. I have another value which has an error of 0.5 as well. If I add these two values up, my value is going to be 3. 2 plus 1 is 3, and my error will actually be plus minus 1. And why is that? The reason the errors add up is that 2 plus minus 0.5 means that the value could be anywhere between 1.95 to 2.5, not 1.95. It could be anywhere between 1.5 and 2.5. You get 2 plus minus 0.5 means that it could be lying anywhere between 1.5 to 2.5, right? 1 plus minus 0.5 means the value could lie anywhere between 0.5 to 1.5. So the point is, it's a big range. The error is giving you the range that the value could lie anywhere between these two values. Now imagine you're adding them up. So what is the maximum value you can obtain? The maximum value that you can obtain is, you take let's say I'm adding them up. What is the biggest value I'm going to get? So maybe this value is actually 2.5 and maybe this value is actually 1.5. So what is 2.5 plus 1.5? That's going to give me 4. What is the smallest value that I can get? So maybe this value is actually 1.5 and this value is actually 0.5. So what is 1.5 and 0.5? That's going to be 2. So you can have a look that my range is now 2 to 4. So it's basically 3. I mean, 2 plus 1 is 3. But the value could lie anywhere between 2 to 4. So that's plus minus 1. Is this clear?
Yes sir.
So, but just keep it simple. Okay? Keep it simple. Whenever two values are getting added or subtracted, the errors, they add up. Okay? So that's why I'm multiplying it by 2, because I'm subtracting two values. Nishwa, is this clear?
Sir?
हाँ जी.
Sir, multiplying it by 2, जैसे आप 0.05 को multiply by 2 करें तो ये addition की तरह ही है.
ये इधर है. Subtraction आई है, addition नहीं है.
नहीं, आपने कहा ना कि एरर ऐड अप हो जाता है,
हाँ.
तो इसको इससे कैसे रिलेट कर रहे हैं आप?
नहीं, जब भी आप वैल्यू सब्ट्रैक्ट करोगे, ये एग्जांपल ये है ना कि दिस वन हैड एन एरर ऑफ क्या था एरर, +-0.05 था ना इस रीडिंग में. What is the error in the other burette reading? That's also plus-minus point. How did you calculate the difference? You subtracted the top one from the bottom one, right? So that means the whenever values are subtracted or added, the errors add up. यहाँ पे जो error होगा ना इस value में, that's going to be +-0.1. ठीक है, is this clear?
जी सर.
ये मैंने तो शो भी किया था ना कि I gave you simpler values, like if you have 2 +-0.5, if you have 1 +-0.5, let's say if I add them up, so this should come out to be 3 and the errors add up, that should come out to be 1. So that means, so I showed you that 2 +-0.5 could be anything that's between 1.5 to 2.5. 1 +-0.5 could be anything that's between 0.5 to 1.5. So agar aap add up karoge, it's going to be 4. This is going to be, smallest value is going to come out to be 2. So that means that exactly fits this range. Okay, anyways, चीजें simple रखो, ठीक है? Just make sure that you know this. It's a physics thing, ठीक है? People who've taken AS physics, they've studied this in a lot more detail. Adding or subtracting two values, the errors add up, ठीक है? And what is the error? The error is always the smallest graduation divided by. It's always the smallest graduation divided by 2. And also remember, when does addition and subtraction happen? Normally, whenever you take burette readings, whenever you take any burette reading, you're actually calculating a difference. Not only that, whenever you take mass readings as well, so you took mass readings as well. So the first value is going to have some error. The second value will also have some sort of error. Mass is always normally calculated using a difference. It's the mass of boat plus brass. It's the mass of boat after you've transferred all the brass. So it's the mass of empty boat. So mass values are also calculated after taking a difference. So yahan pe bhi na, the error is going to get added up. It's going to double up. Ye bhi clear? Is this part clear? So you should always watch out for this. Okay, when is a value being calculated by taking a difference or by adding two values up? Let's take the next one. Other than the change in apparatus, so suggest one change in the experiment which would lead to a reduction in the percentage error. So what is percentage error? Percentage error is this thing. So now he's saying that without any change in apparatus. Now apparatus can reduce the error. There are two ways of actually reducing the percentage error. One is you decrease the error. How do you decrease the error? Use a more accurate apparatus. Like if I had used a burette that had a much smaller graduation, the error would come out to be much smaller. Okay? So one way is you can simply decrease the one way is you can simply decrease the error by using a more accurate apparatus. But in this case, he's specifically saying that don't use an accurate apparatus. The other way you can change the percentage error is if you have a bigger value. So if you have a bigger value, the error over the actual value, the percentage error would automatically decrease because your denominator would be much bigger in size. So that's another way of decreasing the percentage error. So how can you do that? One way you can do that is use larger mass of brass. What would that do? That would increase your burette values. More Na2S2O3 would be used. And what will happen is that if more of Na2S2O3 would be used, you'll get bigger burette readings. In this specific case. Okay, is this clear? So remember this. The errors wala in every paper, this is going to come and it's going to be very important. Always remember smallest graduation. And another thing about this is, if they hadn't told you it's 0.1, you can always check the smallest graduation. The smallest graduation is over here, it's 0.1, not 0.01. Because yahan pe na, he can't actually, I mean, most of the time this is 0. So that means the second decimal place, he can't read from the apparatus. So that means the apparatus is not showing the second decimal place. The smallest graduation is the first decimal place. Because over there he could read 5, over here he could read 2, he could read 9, but on the second decimal place he can't read anything. So the apparatus is not showing you any values for the second decimal place. The reason you use the second decimal place is because sometimes the value could lie exactly between two graduations. So they sometimes use 2.5, but otherwise the apparatus will not have this 5. This is a 40.2 and a 40.25. So the apparatus would be showing 40.2. The apparatus would be showing 40.3. The apparatus would be accurate up till the first decimal place. The reason he was able to actually go up till 2 decimal places was that maybe the solution was somewhere between them. So he stated that it's 40.25. So always remember and watch out for that as well. Okay, what is the smallest graduation? It's the one where you could, it's the smallest reading that the apparatus is giving. Don't focus on the decimal places, focus on, okay, what decimal place is the apparatus reading the value still? He could read 5, he could read 2 over here, 9 over here. This 5 does not count. The 5 just suggests that it's somewhere between the two values. But anyways, in this case, he already told you that this is 0.10. So next one. As a calculation, step 1 and 8 were repeated, this time using 1.88 grams of brass. अच्छा पिछले पॉइंट क्लियर है, उस पर कोई क्वेश्चन नहीं है किसी का?
Yes, sir.
अच्छा next part is कि you've got the end point of the
मेरा
picture.
एक क्वेश्चन है, हर P5 का एक ही पैटर्न होता है?
हाँ, almost. Or every P5 has a completely different problem statement. Okay? The question could be completely different.
Yes, sir.
But the pattern is kind of exactly the same. Okay? The question could be on anything. It could be on anything. It could be something that you've studied in chemistry. It's something that's you've never actually seen before. But the pattern is kind of almost the same. So it's a moles question. Okay? This one. Step 1.8 were repeated, this time using 1.88 grams of brass. The endpoint of the titration was found to be 16.50 cm cube. The equations for the reactions are shown. So this is what was happening, that when he added copper +2, it reacted with Ki. He said that in step 6. So the white press plate was probably copper I. This was the white press plate that was formed, and he said that it was forming a brown solution. And then he added thiosulfate, so it reacted with the iodine and ended up forming I-1 NS406. Determine the number of moles of I2 formed when excess of I2 was added to 25 cm cube of solution B. So in step number 6. So this was your 25 cm cube that was added. And he's saying, figure out how many moles of determine the number of moles of I2. We need to find the moles of I2. The way you're going to do this is that this is the titration that happened. Thiosulfate was added. This is the titration that you calculated. Your answer for that was volume. It came out to be 19.7 cm cube. So this came out to be, the volume came out to be 19. And somewhere above, he also gave us the concentration of thiosulfate. Somewhere, either thiosulfate, carry out a titration, aqueous iodine produced against 0.1 mole per dm. So it's 0.1 mole per dm cube. So the concentration of the thiosulfate is 0.1. अब पहला काम करो, find the moles of thiosulfate. That's 0.1 concentration times volume. That's 19.7 divided by 1,000. Okay, now how many moles are we getting? That's
1.97 into 10 raised to the power minus 3.
actually you're getting 1.97 into 10 to the power minus 3 moles. So in your 25 cm3 flask, so in your 25 cm3 flask, where you were titrating all of this, how much iodine? Iodine moles would be half of that, right? So what are the moles of iodine? इसका half क्या बन रहा है?
(9.84 into 10 raised to the power minus 4.
कितना है?
9.85 into 10 raised to the power minus 4.
10 is for minus 4 moles, right?
Yes.
Okay, so that's your iodine moles. So the next part is, I'm using 19.7. He said that there was another titration, they were actually using 16.5. Actually, because he was doing this for a completely different titration. I thought we were doing it for the previous one. So one mistake that we made was that it wasn't 19.7, it was actually 16.5. Can anyone redo the calculation? That we're actually doing this for 16.5, not 19.7. ये वाले जो होंगे ये तो आ जाएगा, that's going to be 1.65. So what is half of that?
8.25 into 10 raised to the power minus 4.
So those are your moles. Then he says, use your answer to calculate the mass of copper 2 plus ions in solution A, and therefore the percentage by mass of copper in the sample of brass. If you are unable to calculate, so the next part is we found out the moles of iodine in the flask over there. Now remember, previously he had made a 250 cm3 solution. But if you remember the steps, he had originally made when he had dissolved the brass and he had added Ki and he had added distilled water. It was step number 6. Like if I go back to step number 6, when he was dissolving it in Ki, a white precipitate and a brown solution was formed, and which step? Step number 6. As a solution A was diluted, so it was a 250 cm3 solution to start with. He did all the reactions, he added Ki, etc. But when he was titrating for the reactions, he was only using 25 cm3 of solution B into the conical flask. एक सेकंड मैं इसको पहले order में देख लूं. Dilute solution A. He diluted it. He's doing it for 25 cm3. Everything is being done for 25 cm3, while the original solution that was produced was a 250 cm3 solution. So all the moles that we are calculating is for the titration part. So we had how many moles of iodine? We had 8.25 times 10 per minus 4 moles of iodine that were produced in the first reaction. So what would be the moles of copper ions? That's going to be double the moles of iodine according to the ratio in the equation. So what are the moles of copper ions? इसको आप double कर लो and that will give you So that will give you 1.65 times 10 per minus 3 moles back again. So let me just repeat, okay, you did titration, thiosulfate was added, you found the moles of iodine, all that iodine was produced in the previous reaction, and you double the moles to figure out the moles of copper ions. Okay? So you're able to figure out the moles of copper ions, but this is during titration. This is only for the 25 cm cube that underwent titration. So the original solution, that's 250 cm cube. So how many moles would they be in 250 cm cube? That's going to be 10 times more. So it's going to be 1.65 times 10 power minus 3 multiplied by 10. So you're going to get 1.65 times 10 to the power minus 2. So is this part clear that your original solution was actually a 250 cm cube solution? So you were able to find the moles in 25 cm cube, but the original one was 250 cm cube. So you multiplied it by 10. You clear? Is this part clear?
Yes.
And finally, what you have to do is you have to figure out the percentage by mass of copper in the sample. So first thing you have to figure out is convert the moles of copper into mass. So copper's AR is given. So mass kya hogi? That's going to be 1.65 times 10 power minus 2. And it's going to be multiplied by 63.5. So what are we getting? It's okay answer.
1.05.
So you're getting 1.05 grams.
Yes.
So you're getting 1.05 grams. And after that, what are you going to do? You have to find the percentage by mass of copper. So how much copper was actually used? In this particular titration, he was using 1.88 grams of brass. So out of 1.88 grams of brass, you have 1.05 grams of copper times 100. So what is the percentage that we are getting?
$55.7.
So you're getting 55 point. And that's going to be your answer for this one. The next part is that a small percentage of silver is sometimes found in some brass alloys. Silver, right? So when concentrated nitric acid is added, silver metal is oxidized to silver ions. So basically your solution has some silver ions now. At the end of step 6, the silver ions no longer remain in solution. So what happens? What happens to silver ions? Why don't they remain in the solution in step number 6? So what is going to happen in step number 6? If the solution that you have has some silver ions, what's going to happen?
Precipitate of silver iodide.
It's a test for I -1. So it will form a precipitate of AgI solid. So the silver ions will react in step number 6, the Ki that's being added, and they will form a precipitate of AgI solid. Here, that's your 19-mark question, the first one. As a second one, it's about graphs. So the second one is the activation energy E of the reaction between magnate 7 ions and ethane diode ions C2O4 can be determined as follows. Use a pipette to transfer this much KMnO4 into a boiling tube. Use a second pipette to transfer C2O4 into a second boiling tube. Place both boiling tubes into a water bath at approximately 50 centigrade. So the 2 test tubes, separate test tubes. One has thiosulfate, one has ethane diode, The other one has KMnO4. He then takes them to 50 centigrade, both of them. He records this constant temperature, pours the C2O4 into the boiling tube containing MnO4 and immediately starts the timer. So pours one into the other one, starts the timer, continues to stir the mixture during the reaction. When the reaction finishes, stops the timer and records the time. I'm going to assume that the reaction is, the way it's going to finish is that the KMnO4 might go colorless. Maybe that's what's going to happen. Anyways, it's a rate of reaction question. He reacts to things, starts a stopwatch, and figures out when it's going to stop. And he records the temperature, the time it's going to take. And he repeats the experiment at different temperatures. So what he's probably doing is that he's measuring the rate of the reaction. The rate of the reaction is inversely proportional to the time that the reaction takes. So he's trying to find out the rate of the reaction at different temperatures. To calculate 1 over T first, fill the table, 1 over T. 1 over T is, you calculate it with the other, what's 1 over 333?
Three point zero into 10 raised to the power minus 3.
So, that's 0.003. And use 3 significant figures because this value is 3 significant figures. What's the next one?
3.09 into 10 raised to the power minus 3.
0039.
0031 actually.
031. What's the next one? So make sure open this paper at your end as well.
0.00317.
317. और उसके बाद क्या?
0.00323.
Last one.
Zero point zero zero 329.
So that's the first row. What about the next one? Log. You have to take log. So what do you get for log? What's log 11?
1.04.
Log 35.
1.54.
Log 76, that's
1.88.
145, that's 1A.
2.16.
This one's 2.16. Last one.
2.45.
2.45. Okay. As a part A, an experimental procedure step in the method is required in order to be able to calculate the average temperature of the reaction mixture throughout each experiment. State the extra procedural step that needs to be done. What does he mean by that? What's an extra step that needs to be done? What he's saying is that when he had recorded the temperature initially at 50 degrees centigrade, he started the reaction. But he wants to know the average temperature of the reaction mixture throughout the experiment. So you started a reaction at 333. How do you calculate the average temperature throughout the first experiment? Like if you're doing experiment number 1, what other point needs to be, what other temperature value should you have? Okay, you know that the starting temperature of the reaction was 333. You started the reaction. ये दोनों tubes जो है ना, you've mixed those tubes together. So how do you calculate average? For the average throughout the reaction, I mean, this reaction took 11 seconds. So you want to know the temperature at the end of the reaction. More important is temperature at the end of the reaction, because then you're going to calculate the average. For example, you started the reaction at 333, and maybe once you reach the end of the reaction, the temperature had dropped to 320. So that means the average is somewhere between them. You take the two values and then you divide that by 2. Complete the empty column. Suggest by an experiment with an average temperature of 70 would produce a result that is less accurate than the other experiments. 343 Kelvins. You could explain today. Why would 343 Kelvins, if you do the experiment, the above experiment, why would it be less accurate? Remember, you're calculating time. And we had discussed earlier that less time. We had discussed that larger values, there's less percentage error, because the error in the watch is going to be exactly the same, no matter what value you take. You measure 11 seconds, maybe your error in the stopwatch or your reaction time error, etc., that's 2 seconds. Okay, maybe sometimes you're 2 seconds late, maybe sometimes you're 2 seconds earlier. But when you're measuring 284 seconds, the error remains exactly the same. So what happens is that bigger values have a smaller percentage error. 343 Kelvins is a higher temperature. At a higher temperature, the reaction is going to be faster. You'll have a faster reaction. The inside temperatures, 343 is actually the higher one. So you'll get a faster reaction. If you get a faster reaction, it will be quicker. And that will create errors, because the time value, it's 11 seconds. Even measuring 11 seconds is like going to be less accurate. So what you're going to do is, agar 343 pe jate ho na, the time might drop to 5 seconds maybe. So that the time would be too short, and it would be, the percentage error would be very high. Okay, is this clear? Clear? Clear?
Yes, it's clear.
That's the next one. Identify the dependent variables. That's obviously, you're measuring time, right? So that's your dependent variable. What's the independent variable? It's your temperature, basically. You are the one who's controlling the temperature. The time depends on the temperature. So that's your dependent variable. Then you have to plot a graph. So we can try and plot a rough graph. Remember, 1 over T is basically rate of a reaction, and log T is basically your time. So if I want to plot this quickly, it's at a log over T. The first one is what value that's the first value was 0.003, right? And log of T came out to be 1.04. So 1.04 might be somewhere. This is 1.1. So 1.04 would be right at the bottom. Probably this one. The second point in the table was 0.031, 0031. And it was 1.54. So 1.54 would be, this is 1.5, 1.54 would be one block, be 2 blocks. That's going to be this. The third value on the table was 317. So what's 31? Where's 317? So 317 would be, I think, this one. And at 0.00317, it's 1.88. So I've got 1.8. This over here is 1.9. So 1.88 will be one mark below that. And then after that, it's 0.00323. The 323 is going to be this one. So make sure practice drawing graphs, okay? Easy लगता है, लेकिन it's not that easy. People make a lot of mistakes when they're, so always try and practice making graphs. So that's 323, and spot an error if you find some, or 2.16. So this is 2. So that's going to be 2.16. And so on. We've got the last one, which is 0.00329. So 329 is this one. And it's 2.45. So 2.4 and 5 would be over here. Okay, anyways, we have a graph in front of us. The other thing is you're just going to draw a line. So make a best fit. It looks like a perfect straight line. Okay, so you can probably use a ruler to make a. Remember, equal number of points above and below this line. The next part of the question is that he's saying that the equation for the line of best fit is shown. It's this one. And always remember, any equation could be written in the form of y is equal to mx plus c. So this is y, this is mx plus c, which is a constant. So y over here is log of t. So what is the value of m? M is actually 1 over t. You had plotted these things. You had plotted log of t versus 1 over t. So that 1 over t is basically your x. So I can rewrite the equation. The m over here is basically E naught over 2.303. R is your gas constant. And 1 over t is your x plus c. So if I write it in terms of y is equal to mx plus c, I plotted log of t versus 1 over t. This thing over here is my constant, is my gradient, which is m. And he's saying use your graph to determine the gradient. So you can use your graph to determine the gradient. So we're going to, on your graph, always remember to draw a rough triangle and write those values. So for example, over here, my y over here is, points, my y over here is 2.45 and my y over here is 1. So coordinate number 1 on the y-axis is 2.45. Coordinate number 2 is 1. What's the x-axis? The x-axis over here was 0.003, and over here it was 0.00329. और फिर आप इसका gradient निकालो. How do you calculate gradient? You subtract the y. Minus 1 divided by the x, which is 0.00. 329 minus 0.00. Okay, in this case, whether I'm using the same coordinates. I mean, I use the first one and the last one. But remember, it depends on your line. Okay? If the coordinates are right on the line, then you can use them. If they're not on the line, you have to use coordinates on the line. So either I'm just assuming that they are on the line. So what do we get? What's the gradient? So remember, advice to everyone, draw graphs. Okay? The biggest mistakes that you have are usually in the graph. Because if you get the graph wrong, you get a lot of things wrong. I said, क्या 2 times 10 power minus 4. So that's a gradient. And determine the activation energy now. Now remember, I told you that the way this equation was written, the M was your gradient, which was E naught over 2.303 over R. And R, I think, is given over here. That's your gas constant. So we plotted log of T versus 1 over T, Y and X were plotted, and we found the gradient. So we found the gradient. So it's E naught. Sorry, EA. That's not E naught. 2.303 over R, which is 8.314. And that should be equal to 2 times 10 power minus 4. That's my gradient from the graph. Dev Dada, what is EA coming out to be? Yeah, if you solve for EA. इसे calculate किया.
To revise the gradient 5,000.
The gradient is, what is coming out to be 5,000? EA?
Gradient.
The gradient 2 times 10 power minus 4 नहीं था. It's not 2 times 10 power minus 4. What is it?
5,000.
So if it's 5,000, no, it's actually 5,000. So solve for EA now. So 95735. That's a 95735. Pata nahi if this is the, hopefully this is the right answer, 95735. I'm just going to finally check this one, just 1 second. So they didn't give the answer. They just told you how to do this. This was how you're going to do this, and you found it. And that's it. And you're being asked to find out the units as well for this. So what are the units for EA? I mean, for this, you would have to sort of figure this one out. EA is activation energy, right? So activation energy units, I mean, you can either solve it or it's, since it is energy, it's going to be in joules or kilojoules per mole. But from this equation, can you try and solve? I mean, they're probably not going to expect you to do this because solving ये दिया हुआ है joules per mole per Kelvin, right? Then you have temperature. You can actually solve this. Okay, let's try and solve this. Okay, log of T is basically log of time. It's going to be a constant. Gradient aa gaya tha, so it's going to be in joules per mole. The Kelvin part is going to get cancelled out because it's being multiplied by temperature. So it's going to be joules per mole. That's about it. Okay, that's going to be your unit in this case. So okay, we're done with this paper. The problems है तो वो बता दो मुझे फिर. The log would probably remove units, okay? So that's why everything else is a constant. This one would probably have no units. So you're left with this part. It's EA divided by a constant. R is joules per mole per Kelvin. And this R is being multiplied by time, by temperature. Big T is temperature. So temperature is Kelvins. So the Kelvin part gets cancelled out and you had a constant over here, which was your gradient. The gradient was a constant, right? So if you take joules per mole to the other side, it's going to be joules per mole. Zoa, is this part clear?
Yes, sir, it's clear. So I had doubts in paper 2019, October, November, paper 43.
Just 1 second.
Okay.
Concept 2019?
Yeah, October, November 2019, 43.
So which question?
Question 2, CI.
Actually, sorry, I opened sorry, wrong one. This one is the wrong one.
Yeah.
Yeah, yes, yes. Just 1 second. This is 9701, yeah. Two C part 1, right? So it's this one. An experiment is carried out in which the initial concentration of ClNO2 is 2 times 10 power minus 4. So what is the initial concentration? It's ClNO2 is 2 times 10 to the power minus 4. And he says a large excess of NO is used. The initial rate of the reaction is 1 times 10 to the power minus 4. So you're given the rate of the reaction, right? So rate of reaction is what? How quickly does the concentration of ClNO2 change over time, right?
Yes.
Okay, that's change in concentration over time. That's what rate is. So you're plotting ClNO2 concentration. An initial concentration is given. A large excess of NO is used. The initial rate of the reaction is 1. So you know the rate as well, 1 times 10 to the power minus 4. The rate of the reaction is assumed to be constant. So it's a constant rate. So that means whatever is happening, the concentration of your reactant is decreasing at a constant speed. Is that clear?
Yeah.
For the first 0.2 seconds. So draw a graph on the grid to show how the concentration of ClNO2 varies for the first 0.2 seconds. We know the first point. What happens after 0.2 seconds? So remember, this is a so So what happens after 0.2 seconds? So we need to find this point, whatever that point is. So the gradient is your rate, right?
Yes.
So how do you calculate rate? Rate is how do you calculate the gradient?
It's at 0.2, right? You've marked it at 0.15.
Acha, jaldi kar de 0.2. Just 1 second. So it's probably going to be at 0.2 somewhere, right? So I made a rough line. It's a constant rate. There's a constant decrease in gradient. Starting with what's the x-axis over here? That's 0. What's the y-axis? That's 2 times 10 to the minus 4, right? What's the x and y-axis over here? This is 0.2, and the y-axis is, I don't know what the y-axis is. I don't know what the final concentration is, right?
Yeah, how do you find that?
So I know the gradient, I know the value. It's
Okay,
so
I
what's
see.
y2 minus y1? That's going to be y2 minus 2 times 10 to the minus 4, right? Divided by x2 minus x1. That's going to be 0.2 minus 0. And I know what the value is. The rate of the reaction is 1 times 10 to the minus 4. Okay, that's given over here. This go solve for quickly solve this. What do you get? 1 times 10 to the minus 4 into 0.2. Achha, sorry, make sure one thing. It's a negative gradient. I mean, the concentration will decrease, right? So it's a negative gradient. Now find out what the rate is.
It's 1.8 into 10 power minus 4.
ठीक है,
Yeah,
तो
it's
यहाँ पे so यहाँ पे जाकर 1.8 times 10 to the minus 4 plot that. ठीक है, he's asking you to draw a graph on the grid. So you plot this other point exactly where it is, and then make a straight line from that point.
Okay, understood. And I think C2, I've marked C2 as well.
You're saying after 20 seconds, the concentration of CnNO2 remains constant, right?
Part
So
2.
Part 2,
No,
reduce the
two.
concentration of
Yes.
NO2 produced at 0.2 seconds. The concentration of NO2, right? So this is the concentration of kitni decrease we it came to the it was 1.8 after into 10 to the minus 4 after. So initially it was 2, now it's 1.8. So that means it decreased by what amount? It decreased by 0.2 times 10 to the minus 4, right? Is that clear?
Right.
So the reaction kaun sa ho raha hai? The reaction is this one. So if the concentration of ClNO2 decreases by what 0.2 times 10 to the minus 4, the concentration किसकी मांगी थी? NO2 की. That is going to increase by 0.2 times 10 to the minus 4.
According to ratios.
हाँ, मतलब यहाँ पे कम हुई so it
Okay.
reacted. So the other side, that is the amount that's going to increase.
Okay.
A third part, like, why does the concentration of ClNO2 become constant?
Equilibrium reached.
It's going to reach equilibrium, so that means no further decrease in amount of ClNO2. So what was the question?
It's from another paper. 20 March 2021, paper 42.
इसमें कौन सा which question?
Question 4BI.
This one?
Yeah, this one. I didn't know how to solve this.
You remember in a tetrahedral complex, ठीक है, this is from the notes. In an octahedral complex, where are the ligands approaching in an octahedral complex? On the axis or between the axis? Okay, let me
On
just
the axis?
take on the axis now, so it's harder to keep electrons on the axis. Let me just show you. Okay. ऐसे यहाँ पे notes में ना कि probably above this one. So remember, in an octahedral complex, all the ligands are approaching on the axis. So it's harder to keep electrons in the green orbitals over here. So the d subshell orbitals on the axis, they reach a higher energy level. So dx square minus y square and dz square are at a higher energy level. And the ones that are between the axes are at a lower energy level because they're going to face less repulsion.
Wait, sir, I didn't get
Yeah?
that.
Hmm?
No.
ये
I
था ना
didn't
कि
understand. Okay.
अच्छा ये था कि when a transition metal ion has these d subshells inside it, right? So when the
Yes.
ligand comes in and attaches on the outside, right? So
Right.
what happens is when you have an octahedral complex, that means all the ligands are on the axis, right?
Yes. Okay.
So now your d subshell inside the copper ion had 9 electrons in it. So there were 9 electrons inside the copper ion. But now something happens. The d subshell were identical. All the 5 d orbitals were identical. dxy, dxc, dx square minus y square, dz square. They were all identical. But now they're no longer identical because the axis pair, water has a lone pair, right? If you have electrons in this green orbital over here, so it's going to be harder to keep electrons over here. Do you get the point?
Right.
If there's a water molecule over here, it's going to be harder to keep electrons in the green orbital over here. So keeping electrons on the axis is going to be difficult. Keeping electrons between the axes in the pink ones, that's going to be easy. So your d subshell is now going to have 2 energy levels. Instead, previously it was just one subshell, degenerate subshell with the same energy level, but now it's going to split up. So the ones that are on the axis, harder to keep electrons. The ones that are between the axis, easier to keep electrons. Those are your low energy orbitals. Those are your higher energy orbitals.
Okay.
So that is what happens in an octahedral complex. So answering the first part, the ones on the axis, 3d x square minus y square and 3d z square, and the ones they would be harder to keep electrons, higher energy, 3d xy, 3d yz, and 3d xz are going to be easy to keep electrons, right?
Yeah, makes sense. And for tetrahedral.
So for tetrahedral, it's going to be the opposite. Let me show you tetrahedral class. So for tetrahedral, the point is that in a tetrahedral complex, if I show you a tetrahedral complex, where is it? I say in a tetrahedral complex, the ligands are not, now imagine the same thing, but the ligands are not on the axis. They're at an angle of 109.5. So if they're at an angle of 109.5, so that means if you, by the same logic, it's going to be harder to keep electrons between the axis. Is that clear?
Between the axis?
Because the ligands are all attaching.
They're causing repulsion.
They're causing repulsion between because the ligands are no longer on the axis, right?
Yes.
Those cases, it's going to be the opposite. It's going to be between the axes, it's harder to keep electrons because that's where the ligands are. ठीक है, ये clear है?
Yes, it's clear.
So कौन सा?
I don't have any more questions. Thank you.
सर मेरे nitrogen compound के
नहीं क्वेश्चंस है
जी
वो भेजे थे मुझे आपने?
जी मैंने आपको भेजे थे, उसके बाद मैंने आपको एयर्स भी भेजे थे।
हाँ एक सेकंड है मुझे मुझे एक मैसेज आप करते हो दोबारा, एक एक कोई भी मैसेज कर दो ताकि वो मुझे मैसेज मिल जाए। मुझे पता है कहीं है लेकिन आई कांट फाइंड वो मैसेजेस। अच्छा ठीक है मिल गया। 2016 के फर्स्ट वन 2016 ठीक है। अच्छा 2016 जून 4/1 राइट। तो अच्छा S16 QP41। अच्छा क्वेश्चन 6 राइट।
यस सर।
पूरा क्वेश्चन 6
सर ये पूरा मुझे समझ नहीं आया था।
तो ट्राई कर लेते हैं पूरा ठीक है। So starting with the first one, there's nitrobenzene can be reduced to phenylamine in an acid solution in two-step process. Balance the half equation for this reaction to work out how many moles of electrons are needed to reduce 1 mole of nitrobenzene. ठीक है तो the first part is you just have to balance better the first part, balance the oxygens kitne. There are 2 oxygens over here, you got no oxygen, so there should be 2. So there should be 2 water molecules. The other part is that as the rest of the part kya hota hai? The other part is H's. How many H's do we have? That's 2 and then how do I balance H's? That's 4H plus 1 I guess. The 6H hoga 4H hoga. हाँ sorry 6H है ठीक है, that's 6H. अच्छा now the next part is how do you figure out the number of electrons being gained and lost? ठीक है. Now the point is okay, there's a change in oxidation state and you have to figure out what the change in oxidation state is. अच्छा लेकिन यहाँ पे ना there's an issue. I mean, you know what's happening. There's no oxidation state changing over here. H is +1, H is +1. Okay, O is -2. That's not where the oxidation state is changing. The oxidation state is changing over here. Okay, you had C6H5NO2, and on the other side you have C6H5NH2. Acha, point ye that since both of them have C6H5, finding the oxidation state is going to be difficult, like because you don't know the oxidation state of carbon, you don't know the oxidation state of nitrogen over here as well. Okay, so जब दो unknowns होते हैं, you can't find the oxidation state. But one thing you can do is, since you have C6H5 on both sides, just cancel it out, okay? Because it's a constant. तो वो जो change जब निकालोगे ना, उसका it won't have any role. Like even if this was I don't know what this is, but even if this was +1, it's +1 over here. So when you calculate change, the +1 will get cancelled out, okay? So do you get the idea? कि मैंने same चीजें ना I've already cancelled it out just to simplify things. Is that part clear?
Yes sir.
कोई फर्क नहीं पड़ेगा, ठीक है? Even if I don't know what C6H5 is, it's going to get cancelled out anyways. So what is the oxidation state of N in NO2? That's going to be +4, right? Because oxygen is -2 and ये तो पता है ना, it's going to be +4 if I just get rid of C6H5 altogether. Is that clear?
जी sir.
तो यहाँ पे क्या है? NH2 के अंदर it's going to be H is +1, right? So this is +1 and a 2 +1, so N would be -2, right? So your N is changing from +4 to -2, which is a change in of what? How many electrons are being gained? 6 electrons, right? Clear है बात?
जी sir.
So the point was that it's kind of a simple चीज थी ना, that was कि even if you didn't know what this was, it didn't matter क्योंकि change निकालते हुए, and remember this was not the actual oxidation state because इसको तो मैंने ignore ही कर दिया ना, but the change came out, it still came out to be the correct value. क्योंकि change के अंदर ना this factor would cancel out anyways. So the next part, you've got this molecule C6H5NO2 and use oxidation numbers or electrons transferred to balance this equation. First part, 10 goes from 0 to what? It goes to plus, कितना हो गया? 4.
I think 4.
So that's gaining how many electrons? It loses 4 electrons, right? So it loses 4 electrons, right? और ये भी n का निकाला था, NO2 going to NH2, that's a gain of how many electrons? That's a gain of 6 electrons. That's a gain of 6 electrons. और ये याद रखना कि NH2 and NH3Cl will have the same oxidation state. Like even if it's NH3Cl, वो n की निकालो ना, it's going to be x. This is +1 times 2. Cl is -1. So you +1 times 3. Cl is -1. So what do you get? You still get x as -2. X will still come out to be -2. So remember, C6H5 NH2 or NH3Cl, it's the same oxidation state for N. Is that clear?
Yes, sir.
और इधर भी ना I'm ignoring C6H5 क्योंकि वो सेम है ना, तो चेंज में तो उसका कोई फर्क नहीं पड़ेगा, ठीक है, even if you ignore it. अच्छा, now जब ये क्या क्वेश्चन है, ये summer 16 QB41. नहीं, लेकिन ये पार्ट समझ आया कि since I was not able to calculate the oxidation states of the whole things because there were too many unknowns, so the same part, and I just eliminated it because when I'm trying to find out the change in oxidation state, this part will, I mean, whatever the oxidation state of this part is, it's going to eventually get cancelled out जब आप change निकाल रहे होगे, ठीक है? ये part clear है? Is that part clear?
जी सर.
अच्छा, अब अगला part है कि you have to balance it. So remember, electrons gain and loss, they have to be equal. So multiply the first equation by 6. I mean, and this by 4. So this should be 6, 10. क्योंकि 6 से करोगे तो electrons loss will be 24. If you multiply this by 4, the electrons gain will be 24 as well. So I have to multiply this by 4. So that will leave me with how many CLs? That will leave me with, I say CO2 bhi ho sakta tha. I've actually used bigger numbers. I could have just used, balki CO2 use karna chahiye tha. Equations are always balanced in the simplest form. So multiply by 3, that's 12 electrons. Multiply by 2, that's 12 electrons. So 3 SNs. So CLs कितने हो गए? That's 4 3s are 12. So I need 12 HCLs. और बाकी खुद ही देख लो कि H कितना होगा, ठीक है? Okay, how many H's would you have? That's 12H. 3 go over there, so that's कितने H's are there? That's so ये 2 होगा. And you multiply this by 2, right? Baki dekh lo, you can try and balance water. But is this clear, this part?
Yes, sir.
So iska baki question bhi.
सर बाकी तो शायद हो जाए. इस पार्ट में ज्यादा मुश्किल हो रही थी.
ठीक है, बाकी आसान हो गई, ये मुश्किल था, ठीक है. लेकिन remember, the trick is that if you want to find the change in oxidation state and you're not able to calculate the oxidation state because of too many elements which are unknown, just get rid of it. Just same cheese and just get rid of it. C6H5, you got C6H5, just get rid of that, ठीक है. अच्छा, next part क्या था? 2016 November.
जी सर.
कौन सा remember 4-1 1 second. और उसमें कौन सा question number 6 question 3 ये question number 6 अच्छा ये first part के ibuprofen, name the other functional group present in each molecule. So he says that there's a benzene. So what is the other functional group? This is an amide. Okay, that one is I think carboxylic acid. That's it. अच्छा फिर वो कह रहा है ibuprofen contains a
पार्ट बताती हूँ इसका
कौन सा
इसका पार्ट आपको बताती हूँ अभी मैं
जो ऐसे कोई ऐसी चीज
इसका पार्ट सी का 2 है शायद पार्ट सी का 2
ये पार्ट सी का 2 नहीं है ना वो बस कह रहा है ibuprofen ये तो आसान क्वेश्चन है हो जाना चाहिए वैसे ये वाला नहीं होगा कोई और होगा आपका
डी का 2 होगा क्लियर नहीं हो रहा वो इतना
ये वाला
सर आप ऊपर से ही देख लें वो क्लियर नहीं हो रहा इतना पिक्चर में मुझे
नहीं वो पिक्चर मेरे से नहीं देखी जाएगी तो मैं अगले पे चल जाता हूँ इसको छोड़ दो ये वो होगा मुझे भेज देना ठीक है अगला कौन सा that's 2016 ही वाला नहीं 42 है सॉरी अच्छा 2016 42 question 7 अच्छा
सर
क्वेश्चन
इसका
हाँ
ई पार्ट है
ई पार्ट राइट ये वाला अच्छा okay V and W can be hydrolyzed using hot HCl draw the structure of the two organic products of the hydrolysis of W तो W amide है ना it's an amide तो amide यहाँ से टूटेगा so one of the products is going to be it's going to be benzene with Br और एक साइड पे ना there's going to be NH2 or the other one is going to be CH3 C double bond O and that will turn into a carboxylic acid. Or remember, if you're using HCl, that's acidic, so amines are basic, so it will become amine ke paas lone pairs hote hain, so it can accept H+O9, so that's going to be produced. The product formed from the hydrolysis of W are soluble in aqueous acid, whereas the precipitate X is formed on hydrolyzing V. Draw the structure of compound X. तो V का है V का hydrolysis वो कह रहा है उसमें ना कोई solid बन रहा है precipitate so where's V V ये चीज है अच्छा V exactly वही चीज नहीं है अच्छा नहीं V अच्छा V के अंदर क्या होगा V के अंदर it's going to be it's an amide as well ठीक है both V and W are amides exactly same है but amide उल्टा लगा हुआ है ठीक है that's the only difference so this side will become CH3 NH2 और वो जो दूसरी साइड है ना वो कार्बोक्सिलिक एसिड बन जाएगी ठीक है that's going to become a अच्छा that's going to become a carboxylic acid तो क्वेश्चन ये कि अच्छा क्वेश्चन ये कि प्रेसिपिटेट बन रहा है X formed on a hydrolyzing V draw the structure और एसिड के अंदर suggest तो वो कौन सा precipitate होगा what's going to happen if the amide is broken this will form amine एमाइंस आर बेसिक, तो एमाइंस क्या करती है, दे वुड प्रेसिपिटेट, प्रॉब्ली वही होगा कि इट विल फॉर्म अ सॉल्ट, कि N का लोन पे रहा, दैट्स गोइंग टू एक्सेप्ट and Cl-1 will be formed. ये क्लियर है बात?
जी सर।
तो वही लग रहा है प्रेसिपिटेट, ये देख लेना मार्किंग स्कीम में, लेकिन मोस्ट लाइकली वही होगा. The other thing with dilute acid, it's not going to react with dilute acid, क्योंकि वो तो खुद एसिड है, तो इसका तो कोई रिएक्शन नहीं हो सकता. The only thing is that you'll get a salt of this compound over here. और क्या है E के अंदर? E तो खत्म ही हो गया. So that's why X is soluble in water. तो हाइड्रोजन बॉन्डिंग करता है ना वो एमाइन है, उसने वो प्रेसिपिटेट बना है. हाँ ठीक है, वो soluble होगा because it's got NH होता है, तो it can form hydrogen bonds, right? वो भी क्लियर है बात?
सर NH की वजह से soluble होगा.
हाँ, N और H हाइड्रोजन बॉन्डिंग करते हैं, वो आपने बताना कि it forms हाइड्रोजन बॉन्डिंग.
ठीक है.
चलो ठीक है. और भी था उसमें क्वेश्चन? वैसे था सी. तो ये कल मैं क्लास होगा प्रॉब्लम्स के ऊपर ही, ठीक है? वो मैं पहले कर लूंगा स्टार्ट, ठीक है? परसों.
सर
हाँ जी,
आपने नाइट्रोजन कंपाउंड्स के पास पेपर किए हैं क्या?
वो कर लेते हैं कल, मुझे आप बता दो, मैसेज कर दो, ठीक है?
ठीक है, थैंक यू.
चलो ओके.
और सर आपने एनालिटिकल के क्वेश्चंस किए थे 2020 से 2022 तक, सर वो उसका PDF अपलोड कर दें प्लीज.
ठीक है, वो मैं करता हूँ, मुझे मैसेज एक, ठीक है मैं कर रहा हूँ.
ठीक है, अल्लाह हाफिज.
ओके.